Hi, my name's Scott. I'm a student here in 580, and I'm going to be presenting today a paper by Mauricio and others. It's basically an empirical study of factors for success and failure in software reuse. And what the authors did is they took a group of projects and selected from those projects those that were focused on reuse. Then they summarized or established variables that represent those projects, and then they studied those variables to try to understand if there was any correlation between the variables and success or failure. What follows in this presentation is a summary of the author's motivation approach, their selection criteria, the questionnaire for the folks on the projects, variables, success criteria, their data analysis results, conclusions, and a little bit about their method. So let's go to slide 2. What was the motivation to complete this study? Systematic reuse is generally regarded as an efficient way to increase software productivity and quality. And there has been a lot of research on the technical issues that are required for software reuse, like repositories and the tools for search and retrieval of artifacts and programming language support. But the authors noted that recent work has indicated that non-technical factors may be also just as important. And so the authors devised this study to better establish what factors lead to success. So what the authors were looking to find out was what's required for success. Does object-oriented technology by itself guarantee success? And also then technical and non-technical factors for success. Let's go to slide 3. So what was the author's approach? Well, this is an empirical study, and what that means is it's the scientific observation of evidence using statistics to indicate a correlation between parameters that no theory has been found to support. And so what the authors did is they selected the projects, they developed a questionnaire to ask or to interview folks about the projects, and then they coded the results of the questionnaire against a set of variables, and then they did some data analysis. Okay, slide 4. How were the projects selected? Well, what they did was they had 288 European Pi projects that were funded by the European Commission, and each of these projects had a lot of data available about them, and so they scanned this information for certain keywords relevance to software reuse, and then so from there they found 32 projects that were focused on reuse, and they used these for the study. Okay, slide 5. So what was the questionnaire? Um, the questionnaire didn't require a specific reuse model, and the authors defined reuse as the systematic practice of developing software from a stock of building blocks so that similarities and requirements and/or architecture between applications can be exploited to achieve substantial benefits in productivity, quality, and business performance. So slide 6. So the questionnaire included general information about the company, non-reuse information about the organization and the project, the process employed, the roles, documents, phases, certifications, characterization of the project, the effort or complexity of the project, the duration, the staff size, and so on. Okay, slide 7. It also used incorporated reuse information and more information about the reuse processes. Slide 8, the assets, the repository that was used, and any metrics that the folks used. Okay, so slide 9. After the team coded the results into a matrix, they developed 3 different tables, and these tables represent different groups of data or groups of variables. And just for future reference, all shaded rows in the project are those that are for projects that failed. And the variables, or these tables, were divided into three groups: the state variables, the variables that the company can't manipulate for a specific project, and then the control variables, and these were divided into high-level control and low-level control variables. And these variables, the high level are those that only top level managers can manipulate, and the low levels are those that people on the project and project manager can manipulate. Okay, slide 10. So this is a sample row from table 1, which is the state variables. And as you can see, the variables have quantitative discrete values, and a full table would have 32 rows. And later slides will show you that there are 3 tables. I already talked about that. And let's see here. I just wanted to put this up here because it's a pretty big table, and I didn't want to have it be too busy. But this is what the data look like for project ID A. Okay, slide 11. Here I'm just going to go through the different state variables. There was the software staff variable, overall staff. This is basically the number of people in the organization, and the software production environment, meaning that were they producing a isolated product that where each product was unique and developed from scratch for a specific customer, or was there a lot of synergy between the products that they were producing and were thus part of a product family. Okay, slide 12. This is about the software and the product. Was the software is embedded in a product? Was it standalone? So on. We talked about in class about software process maturity models, and they used a CMM level 3 or higher for their highly mature processes, and they also used ISO 9001, which is something we talked about in the class 2. The application domain is just who they were selling, what industry they were selling the products into. Okay, so type of software: was it embedded? Was it technical? Was it business? This is slide 13. Slide 14. This is the size of the baseline, and then the development approach. We talked about this in the class 2, which was object-oriented or procedural. Okay, also slide 15, the staff experience. This is, represents how many years of experience the team has. And so to summarize the state variables, the data contains small and large companies working in a variety of domains, producing products and processes that are embedded and have a high commonality between applications. Okay. Okay, so slide 16. The authors tabulated and looked at these state variables, and they realized that nearly 40% of the projects were judged to result in failure. And so what they needed to do was they need to understand why these failures occurred, and so they looked to the control variables to explain this. So slide 17. This is table 2, or the high-level control variables. These, again, are only the top managers can manipulate these. And so you have I just wanted to put these up here so you can see what the variables are. Slide 18. These are the low-level control variables. And again, this is project A, low-level control variables. So you can see there really aren't a lot of variables. There's not a lot of complexity in this study, but they were actually able to generate a lot of useful information. Okay, slide 19. So here I'm going to go through the high-level control variables. First, the high-level variable was is top management committed to the project, and another was key reuse roles introduced. Did they have a reuse manager or asset owner? Slide 20. Were reuse processes introduced? Were non-reuse processes modified? And slide 21. Did they have a repository? Did they address human factors? Slide 22. So you can see that table 2